Hi everyone. So with the continuation of the previous topic on the homogenization, let's see about the one of the product that is being manufactured in the dairy industry. So that is nothing but the milk powder. So we all know milk, actually the first byproduct from the milk is the powder. So how it is manufactured. So let's have just an overview of the how milk it is being globally, how it is utilized. So currently when we look into the statistics of the milk powder, currently worth of $10.9 billion, and it is expected to reach around 15.5 billion by 2023. So mainly that infant formula is the of the main use. So it is top companies like Fontra, Nestle, Arla Foods and Lactalis, etc. They are contributing a much major part for the manufacturing of the milk powder. So the need has been going to give a market a very vague, the very wide area. So looking into the market size, usage and the key companies. So as we already discussed, the usage is mainly to most milk powder, 51% is being targeted to the use of the infant formula powders only, because that provides more essential nutrients for the babies, as well as other significant uses milk powder is used in the confectionery and the bakery items, as well as in the dairy products also. So the key companies are also being they are producing more capacities and for to meet out the global distribution networks. So those are the companies that they produce the milk now, in a percentage of more in nowadays. So coming into how it is being produced, first the raw milk reception and the pre-treatment. So mainly the first thing is quality standards of the milk has to be taken into account. So the raw milk has to be checked for the bacterial count, for the somatic cell count, and for the antibiotic any residues if present any. So the bacterial count should be always less than 100,000 CFU per ml. Only then it will ensure a very safety, and it will prevent the further spoilage also during or after processing. Okay, so next is the somatic cell count is also plays a major role, because somatic will indicate whether the cow has a good udder, that is it determines the health of the cow in order to prevent the quality defects also. Antibiotic residues nothing but they must be completely absent in order to meet the regulatory requirements and to satisfy the consumer safety standards. Next is the processing. How we go into processing is, first we go for filtration, cooling, and then standardization. Filtration is nothing but in order to remove all the extraneous matters to give a final smooth product, we filter, then we cool down to 4 degrees Celsius within 4 hours of the received in the reception, in order to inhibit the bacterial growth and to maintain the freshness of the milk. Last, standardization is mainly nothing but they are adjusting the fat percentage in the milk to produce the whole milk powder, in order to ensure a consistent product and composition and the quality of the final product. Next, the evaporation and concentration they go in for by carrying the milk for they carry out the evaporation and concentration by adopting falling film evaporators. So this falling film evaporator employs nearly multiple type of evaporators have been attached, that is it undergoes nearly 5 to 7 stages of evaporation by consuming or reusing the same heat. So these evaporators are designed in such a way that a thin film of milk, it actually flows downwards and evaporates and the evaporation rates will increase as time passes by. The use of the stainless steel construction, it completes the sanitary standards and ensuring the equipment that is clean and maintained safely to prevent contamination and also to ensure the product safety. Operating conditions, when we look into that, this milk solids are being concentrated or at a temperature of 60 to 70 degrees Celsius for carefully and why it is done is to preserve the protein quality also and to prevent the fouling. So mainly at optimal conditions, these parameters are continuously monitored, and based on that adjustments are made. And finally, efficiently the energy is being used, because it requires only 0.08 to 0.1 kilowatt of energy for each kg of one water evaporated. That is, each kilogram of water it gets evaporated, it consumes a less amount of energy only by giving a very high efficiency by adopting this falling film evaporator. So in such way we can evaporate the moisture from the milk. Next is the spray drying process, also can be equipped for the process of producing the milk powder, where atomization, that is through the two fluid nozzles, the milk is being pressurized with the high pressure nozzles to 7 to 30 MPa. So the droplet size is like smaller droplets, the smaller droplets will increase the solubility and will ultimately increase the dustiness. And here drying conditions, if we see the inlet air, that is inside a dryer, the air inlet will be 150 to 220 degrees Celsius, and outlet will be 70 to 90 degrees Celsius for a very short duration. At that time, that particular uniform drying and powder deposition on the dryer walls is being attained. So at last we are targeting the moisture content between 2 to 4%, which ensures a very good shelf life stability of the product. And also we are going in for using fluidized bed dryer, and also cooling technique is also adopted in case of to get the milk powder, where secondary drying is being adopted, where it reduces the moisture content to 4% to stabilize the powder, and also to prevent the microbial growth, so that it will extend the shelf life to much longer, and it will maintain the quality of the product. So it optimizes power flowability, inhibits the caking, and it also enhances the dispersibility like during reconstitution process. And the temperature kept here is like 40 to 60 degrees Celsius only, while cooling air is also kept at 10 to 15 degrees Celsius in order to prevent any heat damage and ensure a efficient cooling. So mainly it will preserve heat sensitive material, and also it will optimize the energy efficiency. Airflow is also maintained in order to maintain a uniform drying and cooling is being adopted. Okay, so at last the received powder is being handled very carefully and conveyed. So first it is conveyed using pneumatic system and stored by using silos with a controlled temperature and RH percentage. It is being stored in a very safe condition and packed, and at last it is being preserved. Packing in sense based on the customer needs or the end need, it is being packed at bulks or in pouches or bags. Preservation is done mainly by nitrogen flushing. It extends the shelf life of nearly 18 to 24 months, and also like preventing the some oxidation of the sensitive materials that are present. And also even modified atmospheric packaging also can be implied and utilized for a longer time storages. And coming to the quality control and testing, actually these are the basic moisture content, water activity, solubility index, bulk density, microbial test, and the standards are the main thing has to be tested in the end product of the milk powder that has been arrived. So in future trends and innovation, what will be the technique that can be adopted is we can go in for using membrane filtration, agglomeration, or in sanitation and the sustainability purpose. So main thing like why membrane filtration is, it is more efficient and it give a concentrated protein, so it will lead to a more higher nutritional value, and it will reduce the waste at the end of the processing also. So keeping that in mind, this can be applied in the future innovation also. So based on all this, mainly it will recover the heat and recycle water and reduces the carbon footprints also when we adopt to the recent trends or the recent methods in the future trends. So implementing those sustainable practices, it will minimize the environmental impact, and also it will like conserve the mainly resource or the demand to meet out the a long-term viability, and also for a responsible and a safe manufacturing process. Thank you.